Okay. Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for tonight will be a so-called power factor correction of a motor load by using a power factor corrector, what do you call this, capacitor with the correct value such that we could attain the power factor that we would like, and we could increase the current, and we could increase the power factor. So the important thing here is that by using a power factor capacitor, we should decrease the current, okay? We should increase the power factor such that the current passing through our meter will be lessen. Okay, before I will start the discussion for tonight, this is the one that I bought from Amazon, and this said that this is a power factor corrector. Upon opening this one, the capacitor inside, the value is actually too little. So actually the usage of this one is not actually for power factor correction. Okay? It could contribute to the power factor correction, but the effect is not so much. So actually, this is much more like a so-called high frequency filter. Because when I measure the capacitance of the capacitor inside, it's just only 40 picofarad. 40 picofarad. It's not even a microfarad. Okay? And from my point of view, as an engineer, and I am actually lecturing on the so-called power factor correction, for us to correct the power factor, it should be the value of the capacitor should be in the range microfarad, not picofarad, because picofarad is actually 10 to the negative 9, and that's too small. So for tonight, okay, I will not be using this one. I will be using the one, uh, again, I bought it from Amazon. What I bought again from Amazon is actually a capacitor with the correct value, because when I bought that capacitor, I make sure that the value will be correct for it to correct the power factor. Um, I got some computations here to arrive at the correct capacitance of the capacitor, because what I computed for this what you call this air cleaner is that the correct value of the capacitance should be 7.2 microfarad. 7.2 microfarad. Okay? To raise the value of the power factor to around 95% or 92%. It should be 7.2. But when I go to Amazon, they are not selling 7.2 microfarad. The nearest value that I could buy from Amazon is actually 7.5 microfarad. So it just arrived a while ago, and I assembled it myself. Okay. The basis of this 7.2 microfarad is actually regarding the parameters for this air cleaner here. Okay, I would like to bring out the parameters for this air cleaner. For this air cleaner here, uh, I, I was able to bring out the current, the true power, the apparent power, and the initial power factor. And I would like to increase the power factor of this one to 95% or 92%. For a 95%, what I will be needing is actually 7.2 microfarad. But unluckily, Amazon don't sell 7.2 microfarad. They sell or they sold 7.5 microfarad. So what I bought is actually 7.5 microfarad. So I'm not anymore using this one. Okay. The way and how to correct a power factor is just if you got a capacitor, just connect that in parallel with the load that you want the power factor to be corrected, and that's it. So I don't be needing this one now. Okay. I want to show you the capacitor that I assembled. Okay. The capacitor is inside. The terminal, I connect this one on the two terminals on this one, and I put a 1 million ohms between the terminals as a bleeder resistor. Bleeder resistor meaning when you pull out this one, there should be voltage coming from this one, but to avoid the voltage coming out from this, you should put a bleeder resistor across the terminals, so it will bleed the current gradually, like this one here. Within 30 seconds, the voltage across this one now will be 0. So the one inside is actually a 7.5 microfarad capacitor, 400 volts AC, and across the terminals, I put a 1 million ohms resistor, one half watts, to bleed the voltage across this, because this is very dangerous. Just in case there is a charge on this one, and it so happens that you touch it, you will be electrocuted. And to avoid that one, I put a bleeder capacitor inside between the terminals. And I put this one in a container, and I make it a point that this is sealed, so no one could open this one, because when this one is operating, this is very dangerous. Okay? So this is now the power factor corrector capacitor. This will now be the equivalent of this one, okay? But this one is no good because the capacitance inside is just 40 picofarad. So according to my computation, to correct the power factor of this air cleaner here to around 0.92 or 0.95, the capacitance of the capacitor that I may use will be 7.2, and since 7.2 is not available, I bought 7.5. Okay, so I am now ready to correct the power factor of this one. Okay, I will be plugging in this one now. Okay, I plug it in. So I could not resist one. So this is the load, this is the power factor corrector capacitor. They are in parallel, and they are connected to this kill emitter here, so we could monitor the parameters that will be coming out after the insertion of the what you call this capacitor. Okay, I will try to read the original readings without the capacitor. Without the capacitor, the current reading of the consumption of this one is 0.55 amperes. The true power is 41.7 watts. The apparent power is 66.7 volt ampere, and the power factor is 0.62. Originally, the power factor of this one is 0.62. And we shall now check the parameters upon the insertion of the capacitor in parallel with the load. Okay? So I will start with number one. The applied voltage will be 120. Right? I will toggle this one. The current now is 0.35. When the capacitor was not inserted yet, the current consumption is actually 0.55. Yeah, 0.55. It's now 0.35. So the current was decreased from 0.55 to 0.35. Okay? I will toggle this one. The true power now will be 39.1 watts. 39.1. The apparent power is 42.6. Originally, the apparent power is 66.7. So there is actually a decrease in the apparent power from 66.7 to 42.6. And next one, that's the frequency. And as you can see it now, the next one will be the power factor. The original power factor is 0.62, and this is now, what's the power factor? 0.92. It's 0.92. So by using a 7.5 microfarad capacitor in parallel with the load, okay, we were able to increase the power factor from 0.62 to 0.92. That's more than good enough, okay? Because if this was an industrial load, 0.92 is actually what they call this acceptable to the utility companies. They will not try to penalize you anymore since your power factor is below 90%. But right now, upon the addition of the power factor capacitor, the power factor now is 0.92. Okay, that's 0.92. Okay, I will show you the power factor without the power factor capacitor. I will remove the capacitor. Okay, and let's try to see the power factor. What's the power factor? 0.61. That is without the capacitor. Okay, I remove the power factor capacitor. I remove it. Okay, it's not in parallel with the load, and actually the power factor of the load is 0.61. And to show you that this capacitor really increased the power factor, I will now try to insert this capacitor. I will now try to insert this one. Okay, I inserted the capacitor already. I could handle this one without any danger of being electrocuted. The capacitor is inside. This is sealed. Okay, so you can touch that one. But without the cover, I don't even try to touch the capacitor. I might be electrocuted. So I make this one to be sealed. Okay, I put it down like this. And let's try to see if what will be the power factor now. Could you see it, guys? The power factor is 0.92. Okay? So this is really this is really an improvement from the previous discussion, because the one they sold from Amazon, it's not really a power factor corrector. I think that is just like what you call this noise filter. It's just a filter, okay? It's just a filter, because the increase in the power factor is not so much, 3%, 3 points, 4 points. But this one, it increased from 0.62 to 0.92. It increased by 30%. And actually, you can see it, the power factor is 0.82. Okay? So, if I would like to bring out the summary of this one here, the decrease in current, we could compute that one. Originally, the current is 0.55. It is now 0.36 or 0.35. So if we try to compute the decrease in current, what I computed here is 35%. There was a decrease in the current by 35%. Supposing we are talking thousands of amperes here, assuming your load, industrial load is 1,000 amperes, and you were able to decrease that 1,000 by 35%, so actually you are decreasing that 1,000 by 350 amperes. And that's actually a big decrease already. That's a big savings on your part. The increase in the power factor, originally it was 0.62, it increased to 0.92. So if we try to compute the increase in the power factor, it should be 0.92 minus 0.62 over 0.62 times 100%. There was actually an increase in the power factor by a percentage of 48%. That's a good, what you call this, outcome. So if you got an industrial company, you should know how to compute the required capacitor that must be placed at the service entrance of your company to correct the overall power factor of your company. But the one I'm discussing is just a single load, meaning to say we operate this one 24 hours, okay? And if I could decrease the current by 35% within that 24 hours, I am having some, what you call this, savings in the operation of this one. Because in our house, okay, we operate this one 24 hours, so the air inside our house will be clean. Actually, there is an UV thing inside this air cleaner here. Okay, the air that is coming out here is actually passes through the UV light inside. Okay, I will try to repeat it. The original current of this one without the capacitor is 0.55. Upon the insertion of this capacitor here, the current was decreased to 36 amperes. No, 0.36. From 0.55 to 0.36. Okay? And for the power factor, the original power factor without the capacitor is 0.62. It is now with the value of 0.92. And I would like to show you that the power factor is actually 0.92 with the insertion of the capacitor. Okay? This is the capacitor in parallel with the load. Okay? Totally sealed, so I could handle this one without any problem of being electrocuted. Because a capacitor that is being charged is actually very dangerous. That's why I sealed this one, so no one could touch this one in our house. Okay, I am an electrical engineer and I know how to protect ourselves here in our house. Okay? So, this air cleaner is in parallel with the capacitor now, and I was able to increase the power factor from 0.62 to 0.92. It's now 0.92. Okay? Oh, this is quite an achievement. Hallelujah. This is Professor David J. De Los Reyes. I am not anymore using this one. So from now on, I will be using this one to increase the power factor of this one, air cleaner, from 0.62 to 0.92. And I was able to decrease its current from 0.55 to 0.36. The decrease in the current is 35%, and the increase in the power factor is actually 48%. Okay, I am not using this one anymore. I will be using this one. You see the capacitor inside? Okay, and for my safety, I put a bleeder resistor across the terminals of 1 million ohms. So when I shut off this air cleaner here, and you try to touch the terminals of that capacitor, you will not be electrocuted. Okay? But don't ever try to touch, even though with the bleeder, without the bleeder, okay, before you touch the terminals of the capacitor, you should try to short it like that to remove the charge on the capacitor. But since there is a bleeder capacitor already, it is safe to touch the terminals without being electrocuted. That is actually for our safety. So this is the capacitor which is connected in parallel with the load. Okay, this is the load. Okay, they are plugged into a single, what you call this, this one. This is where they are inserted. The load in the capacitor is inserted here. Okay, this is where the kilometer is, what you call this, plug in, and this black thing here goes to the convenience outlet. So this is quite an achievement for tonight. I was able to bring out an operating power factor corrector, which give me the correct value of the power factor that I have tried to attain. I was able to increase the power factor from 0.62 to 0.92 and decrease the current from 0.55 to 0.36. Like what I said, If this is 1,000 amperes and you were able to decrease your current from 1,000 by 35%, 35% of 1,000 is 350. Actually, that's very big savings already. So if you own a company and you're consuming 1,000 amperes, and by using a power factor corrector capacitor, and you were able to decrease that current by 35%, from 1,000, you decrease that by 35%, 350 amperes. So your total current is now only 650 amperes. That's the only one passing through your meter now. So actually, you decrease your utility bill. Good evening from Los Angeles. This is Professor DBJ De Los Reyes.